Hello, I am Dr. Anubha Gupta from ABES Engineering College, Ghaziabad. In this lecture series, I will explain electromagnetic theory. In this lecture, topic to be covered: Stokes theorem, Gauss divergence theorem, law of electricity and magnetism, continuity equation for current density. First of all, I will explain Stokes theorem. Stokes theorem used to convert line integral into surface integral and vice versa. If any vector A over the line integral dl is converted into the surface integral, then we will take the curl of vector A. This is called Stokes theorem. Gauss divergence theorem. Gauss divergence theorem used to convert surface integral into volume integral and vice versa. If there is any vector A over a surface integral ds, then it can be converted into the volume integral by taking the divergence of vector A. So what is the curl? Curl of a vector field. Curl of a vector field is calculated by taking cross product of del operator applied to the vector field. So del operator is I del over del x plus j del over del y plus k del over del z. This is the del operator. And let vector field is axi plus ayj plus azk. Then curl of vector field is cross product of del operator with vector field, which can be calculated by solving the determinant I, j, k. Del is del over del x, I component is del over del x, j component is del over del y, and k component is del over del z. In a vector A, I component is ax, this is ay, and this is az. So after solving it, we will get I del over del y into az minus del over del z ay minus j del over del x az minus del over del z ax plus k del over del x ay minus del over del y ax. This is the curl of vector A. And curl of vector A is also a vector quantity. Divergence of a vector field is calculated by taking dot product of del operator applied to vector field. Again, we know that the del operator is I del over del x plus j del over del y plus k del over del z. Let vector field A is axi plus ayj plus azk. So the dot divergence can be taken by dot product of del operator and vector field. I del over del x plus j del over del y plus k del over del z. Dot axi plus ayj plus AZK. Del over del X AX plus del over del Y AY plus del over del Z AZ. This is called divergence of A. And this is the scalar quantity. Now I will discuss basic law of electricity and magnetism. First, electric field. Electric field E at a point in space around any charge is defined as force experienced by unit charge. Electric field is force experienced by unit charge. This is called electric field. Magnetic field is a region around a magnetic material, electric current, and moving electric charges. Magnetic field measured in terms of Tesla. Third one is Coulomb's law. It states that the force between 2 point charges is directly proportional to the product of magnitude of charges and inversely proportional to the square of the distance between them. That is, force is directly proportional to the magnitude of charges. These are the charges Q1, Q2. So the force between them is proportional to the Q1, Q2 and inversely proportional, let the distance between them is R, and the force is inversely proportional to the distance between them. So force become Q1, Q2 upon R square, which is the K. Proportional constant is replaced by K and it can be written like this, where K is 1 upon 4 pi epsilon naught, which has the value 9 into 10 to the power 9. And the unit is Newton meter square per Coulomb square. And the unit of epsilon naught is 8.85 into 10 to the power minus 12 Coulomb square per Newton meter square. Now after the basic law of electricity and magnetism, I will discuss continuity equation for current density. Let us consider a surface S having charge Q. Enclosing a volume V. So the total current I emerging from the closed surface S enclosing volume V is minus dq by dt. If the charge is distributed throughout the volume V, so the charge per unit volume is given as Q is equal to rho dV. If this is the equation number 1, this is the equation number 2. So I can be written as minus del by del T. In place of Q, I will write rho dV. This is the current. And we know that the J is equal to I by A. So I is equal to J dot ds. I can write I as a J into ds. And it is equal to minus del rho by del T into dV. Now by applying the here we have the ds and here we have dV. So we will apply Gauss divergence theorem. Gauss divergence theorem, J dot ds is equal to minus del rho by del T into dV. So it become So this ds will be converted into the dv by taking the divergence of j minus del rho by del t dv. And it is a del dot j plus del rho by del t dv is equal to 0. Here dv cannot be 0 because it is, if it is a very small element of volume, but dv cannot be 0. It means this integrants will be 0. Del rho by del t is 0. This is called equation of continuity or continuity equation for current density, which shows that the rate of decrease of charge within the volume is equal to the rate of flow of charge or current. Equation of continuity signifies that charge can neither be created nor be destroyed. It shows the conservation of charge. References of my lecture from the book Introduction to Electrodynamics by David J. Griffith, Solid State Physics by S.O. Pillai, Engineering Physics by S.K. Gupta. Thank you for patience listening.